A race car initially at rest, so let's write that, VI is equal to 0, accelerates at 12 meters per second squared. How much time, that's our find, will it take for the car to achieve a velocity, that's our final velocity, of 78 meters per second? So you have the car over here. I don't know why I think that's a race car, but it's at rest, no velocity. It starts moving, and then over here, at least I'll put some wheels on it this time, it's doing 78 meters per second. We'd like to find out how long that would take. Well, we have initial velocity, final velocity, and acceleration. We want to find time. That's the first kinematics equation. VF is equal to VI plus AT. But we're trying to find time, so we do have to manipulate this time. VF is equal to VI plus AT. Now, before we do anything, let's take advantage of the fact that VI is 0. So that term goes out. We now need to get, let's see, time, just look over there, all by itself. So let's divide both sides by A, and then just spin it around so T's on the left side. These A's cancel, and T is equal to V final over the acceleration. So now we can finally substitute. The final velocity is 78 meters per second. And we divide that by the acceleration, which is 12 meters per second squared. So the meters cancel out. This second cancels this, and that comes up to the top because it was in the denominator of the denominator. So we now have seconds. And what's 78 divided by 12? Well, let's see. 6 times 12 is what? 72. And then take half of 12, that's 6, add that to 72, we get 78. So this is going to be our answer right here. 6.5 seconds. And we'll write that down here, just the answer, 6.5 seconds. And we'll put a box around it. Now, we didn't even have to do that much math for multiple choice question. We're dividing 78 by 12. We know that's somewhere around 6 times 12, 7 times 12. So these answers aren't even close. And this isn't close. So by default, C would be the answer, or you could just get a calculator or estimate it the way we just did.